Welcome to Maths and Science by IITian channel. In today's lecture, I will be talking about trigonometric functions. I will be taking a class on trigonometric functions. It's very vital knowledge which is required for higher mathematics. Trigonometry is useful for higher mathematics and also higher engineering mathematics and also for IIT JEE, CBSE class 11 and also Maths Olympiad. Trigonometric functions and formulae. I deal with class 11 syllabus and we will be going very slow. I will be clearing the concepts so that with the concepts, when they are very clear in your mind, you will be able to solve the trigonometric problems very easily. Concepts are very important rather than taking a problem and solving it. As we move forward with different identities of the trigonometric functions, then we will try to solve the problems from CBSE class 11 and also from IIT JEE examination question papers also. This will be a little bit longer course and we will do it with patience so that we will get the concepts of each and every aspect of the trigonometric functions to the maximum extent possible. Let us go further. Let us take a circle first. Let us develop the concepts of angle. Let us take a circle. In this circle, let center be the origin with 0, 0. O is the origin with x-axis 0 and y-axis 0. Horizontal axis x positive and on left hand side it is x negative, x-axis. It is minus, it is plus. As usual, regular notation. This is y, this is positive towards upwards and this is negative. Now, we will draw a line from center to a point P. Try to understand this concept. And this point P will have a coordinates as x and y. They are variables. That means they vary. As P moves along the circle circumference, x and y will vary. At P1 it will be x1, y1, P2, x2, y2, P3, x3, y3 like this. Let it be P is the locus and let it be P1, let it be P2, then P1 will be like this, P will be like this, P1 will be like this, P2 will be like this. All the points are on the circumference of the circle. As we move from point P to P1 to P2, from point P to P1 and from point P1 to P2, there is an angle. Let us say angle is represented by theta. There is an angle theta measured in the anti-clockwise direction from the horizontal x-axis. This is the horizontal x-axis. Theta is measured in anti-clockwise direction from horizontal x-axis, positive x-axis. And for P1 the angle will be theta 1. For P2 the angle will be theta 2. Are you able to understand? Now, let me draw a perpendicular from point P to x-axis. Let me call this point as Q. For P1, if you draw the perpendicular, it will be Q2, Q1, let us say. For P2, when you draw the perpendicular, it is Q2. That means, as the theta changes, the lengths of initially for angle theta, the sides are, you see, OPQ is a triangle. OPQ is a triangle. Similarly, OP1Q1 is a triangle. OP2Q2 is also a triangle. But the angle changes. Angle POQ is equal to theta. Angle P1 OQ1 is equal to theta 1. Angle P2 OQ2 is equal to theta 2. Here angle is changing. When angle is changing, the sides are also changing. For angle theta, the sides are OP and OQ. Here, from the figure, if you notice, as theta changes, the sides of the triangle, the original triangle is OPQ, O is the origin, P is a general point on the circumference, and Q is the point on the x-axis. The sides are OP, which is hypotenuse, PQ is opposite to the angle theta, opposite side, and OQ is the adjacent to the theta, that is adjacent side. These sides are changing as theta changes from theta to theta 1 and theta 1 to theta 2. How it is happening? Now let us remove the circle and let us draw the triangles. Circle is drawn for understanding. Now, let us say this is the point P and this is the point O, that is the origin, and this is the point Q, perpendicular on OX, that is Q. Second point is, I have removed the circle, please remember that. This is P1, this is Q1, and third point is like this. This is Q2, this is P2. OPQ, For this angle is theta. And for OP1 Q1 the angle is theta 1. And for OP2 Q2 the angle is theta 2. That means the above can be redrawn as these are not to scale, don't worry. The values are variables O, theta, P, Q. 1 and center is same. Center I am not changing. Origin of the circle I am not changing. This is theta 1. And this is theta 2. This is O, P1, Q1. I have only separated the triangle. That's all. O, P2, Q2. Theta is less than theta 1. In this case, theta 1 is less than theta 2. As theta changes, the sides of the triangle are changing. How they are changing? Let us see. From the above triangle, above diagrams, OP is equal to radius of the circle, which in the first diagram I have shown. OP is the radius of the circle, OP1 is the radius, OP2 is also radius. OP is equal to radius of the circle, that is equal to OP1, that is equal to OP2. That means when hypotenuse is same, then how the triangles are changing as theta changes. As theta is less than equal to less than theta 1 is less than theta 2 from the figures what we have drawn implies when this is equal to called as hypotenuse. Radius of the circle is called as a hypotenuse. When theta is less than theta 1 is less than theta 2, what happens? Opposite side, this perpendicular drawn from P to Q increases. That means PQ is less than P1 Q1. PQ, you see, PQ is less than P1 Q1 is less than P2 Q2. PQ is less than P1 Q1 is less than P2 Q2. Do you agree? And at the same time, the adjacent side, this is the opposite to the angle, this is opposite side. Adjacent to the angle is adjacent side. This OP is hypotenuse, that is radius of the circle, that is constant. When radius of the circle, that is hypotenuse, is constant, as theta is less than theta 1 is less than theta 2, PQ is less than P1 Q1 is less than P2 Q2. That is opposite sides. Then what happens to adjacent sides? Adjacent sides are shrinking, they are reducing. That means OQ, this is adjacent side, is greater than OQ1 is greater than OQ2. Are you able to understand? and hypotenuse is equal to OP is equal to OP1 is equal to OP2 is equal to OP3. This is equal to constant. Try to understand the concept. That means theta less than theta 1 less than theta 2 implies when some value is divided by a constant value, the inequality doesn't change. That means PQ by OP, when you divide PQ by OP by hypotenuse, P1 Q1 by OP1 is less than P2 Q2 by OP2. Because OP, OP1, OP2 are constants, this OP3 is not there, sorry, are constants. Hence, when you divide a quantity by a constant, the inequality doesn't change. This also implies when you divide the next line, OQ by OP is greater than OQ1 by OP1 is greater than OQ2 by OP2. Do you agree? This is the behavior of the angle and sides. Now, behavior is okay. Now, every time writing PQ by OP, P1 Q1 by OP1, P2 Q2 by OP2, this will be little bit tedious. Hence, these ratios are given certain names. What are those names? Now we will find out. This is the triangle. Let us take a main triangle OPQ and define the relations, identities. This is O, everything is not to scale, don't worry. This is theta. This is adjacent to theta. This is opposite to theta. This is hypotenuse. Now, what we got? PQ by OP. We want to know what is PQ by OP. For theta angle, PQ by OP is defined. What is PQ by OP? PQ is equal to opposite side by OP is hypotenuse or radius of the circle. In the first diagram which I have shown you. Because it is pertains to the angle theta, we named it as sin theta. We named it as sin theta. Similarly, OQ by OP, adjacent side by hypotenuse, that is equal to, this we will call it as, because it pertains to theta, we will call it as cos theta. Now, one ratio we have found, two ratios we have found, adjacent side by hypotenuse, opposite side by adjacent, opposite side by hypotenuse. Then what happens to opposite side by adjacent side? For same theta we are doing exercise. Now, opposite side is PQ, adjacent side is OQ, that is equal to opposite side by adjacent side, that is equal to PQ by OQ. What is the name we will give? We give some name as, we name it as tan theta. These are the three basic fundamental trigonometric identities from which other identities are derived. Now, we will talk about their behavior. For theta 1, what do you write? For theta 1, similarly, P1 Q1 by OP1, P1 Q1 by OP1 is equal to sin theta 1. OQ1 by OP1 is equal to cos theta 1. For theta 2, P2 Q2 by OP2, that is sin theta 1. OQ2 by OP2, that is equal to sin theta 2, cos theta 2. And what is P1 Q1 by OQ1, that is equal to tan theta 1. P2 Q2 by OQ2, that is tan theta 2. Now, you tell me, when you know the behavior of the angle, theta 1, theta 2, behavior is known, that implies sin theta 1, sin theta 2 behavior can also be known. As the sides behavior is known. Similarly, cos theta 1, cos theta 2 behavior can also be known. Tan theta 1, tan theta 2 behavior can also be known, because sides behavior is known. We are talking about the concepts and behavior of the angles. We are only defining the angles. Please try to understand. We are not going into the problems and direct application of sin theta, cos theta, tan theta in the initial present lecture. We will be understanding the concept. Here you see theta is less than theta 1 is less than theta 2. This is what we have got from our basic knowledge. Now we will try to find out. Theta is less than theta 1 is less than theta 2. What it implies? That implies PQ by OP. PQ by OP is less than P1 Q1 by OP1. P1 Q1 by OP1 is less than P2 Q2 by OP2. This implies when theta is less than theta 1 is less than theta 2, What is PQ by OP? PQ by OP is sin theta. Sin theta is less than sin theta 1. P1 Q1 by OP1 is defined as sin theta 1. P2 Q2 by OP2 is defined as sin theta 2. Are you able to understand? Similarly, theta is less than theta 1 is less than theta 2. That implies OQ by OP minus OQ1 by OP1. OQ by OP less than OQ1 by OP1 less than OQ2 by OP2. That implies what is OQ by OP? OQ by OP is cos theta. Cos theta, OQ by OP is greater than, I think it is greater than, not less than, sorry. It is greater than, greater than. Cos theta is greater than, cos theta 1 is greater than cos theta 2. That means when theta is less than theta 1 is less than theta 2, it implies sin theta is less than sin theta 1 is less than sin theta 2 and cos theta is greater than cos theta 1 is greater than cos theta 2. That means as the angle increases, as the angle increases, as angle increases with respect to positive x-axis, sin theta increases, cos theta decreases. This is what is our observation. This is the concept. These are the concepts which we are required to get clarified. Now, as a homework, please find the behavior of tan theta in similar lines. These are the type of the questions being asked in the examination on the concepts. Now, we will go for one or two values of the sin theta, cos theta and tan theta, and then we will conclude this lecture. Then we will go for the angles, trigonometrical identities, and what are the values, how to remember them in a circle, and circle is to be divided into 4 quadrants, and how positive value, negative value will differ in different quadrants for sin theta, cos theta and tan theta. Now, this is your homework. Second part, in this lecture, what we will do, sin theta we have already defined, PQ opposite side by hypotenuse. Please remember that circle. Opposite side by hypotenuse. This is the circle. This is x-axis. This is point P. And this is the perpendicular drawn on x-axis. This is the center of the. Please always remember the circle whenever you do trigonometry. Everything depends upon the circle. Now, sin theta is PQ, from P to Q, this distance, perpendicular distance on x-axis, PQ divided by OP. This is opposite side, this is hypotenuse, this is angle theta. Sin theta is defined like this. As theta increases, what happens to the sin theta? PQ increases. We have seen. As theta increases, PQ increases. As theta increases, PQ increases. And as theta decreases, PQ decreases. That means theta is directly, because OP, that hypotenuse is constant, theta is directly proportional to PQ, or PQ is directly proportional to theta. From the definition, PQ is related to sin theta. Sin theta is directly proportional to PQ, because hypotenuse we kept it as constant in the circle, that is radius of the circle. Theta increases, opposite side increases. Theta decreases, opposite side decreases. And if theta is equal to 0, if theta is equal to 0, opposite side will be 0. That implies sin theta is 0. Sin 0 is equal to 0. If theta is 90 degrees, if theta is 90 degrees, opposite side will be equal to hypotenuse, because hypotenuse and opposite side will be same. Because hypotenuse, OP is hypotenuse, the P moves here, this is Q, let us say OQ is hypotenuse, not Q, let us say P dash. OP dash is the hypotenuse. That means opposite side will be hypotenuse. If theta is equal to 90 degrees perpendicular, then opposite side will be equal to hypotenuse, which implies sin 90 degrees is equal to opposite side by hypotenuse. Opposite side is hypotenuse itself, hypotenuse, that is equal to 1. That means Sin 0 is equal to 0, sin 90 is equal to 1. From the behavior of the angles, we got these values. Similarly, as a homework, you try to prove cos 0 is equal to 1, sin 0 is equal cos 0 is equal to 1, cos 90 is equal to 0. When you know these two, we can easily say that tan theta is equal to opposite side by adjacent side, opposite by adjacent, that is equal to opposite by hypotenuse divided by adjacent by hypotenuse, that is equal to sin theta by cos theta. That means you need not remember tan theta. Automatically, when you know sin theta cos theta values, you can get the tan theta value directly. In this case, sin 0 is equal to 0. 0 angle is called as 0 radians. When you convert it into radians, 90 degrees is equal to pi by 2. 180 degrees is equal to pi radians. 360 degrees full circle is equal to 2 pi radians. Please remember this. Because for full circle it is circumference is 2 pi r. 2 pi r by r is 2 pi radians. Sin 0 is equal to 0. Cos 0 is equal to 1. Tan 0 is equal to sin 0 by cos 0, that is 0 by 1, that is equal to 0. Sin 90 is equal to 1. Cos 90 is equal to 0. Tan 90 is equal to 1 by 0, that is infinity. Then sin 90 can be written as sin pi by 2 in radians, that is equal to 1. Cos pi by 2, that is equal to 0. Tan pi by 2, that is equal to infinity. I want to conclude this lecture. In this lecture, we have discussed about the behavior of the sides taken in a circle, hypotenuse, radius of the circle, then opposite side and adjacent side behavior with the angle, and we have defined 0, pi by 2 values for sin theta, cos theta and tan theta. For other values and for other formulae, we will develop the concepts like this only, and we will take these trigonometric functions and formulae forward. It is better to learn slowly and learn it perfectly. Learn it perfectly so that you will never forget. Thank you for listening to me. Best of luck to everybody. If there is a value addition because of this lecture to you, kindly share and subscribe to my channel Maths and Science by IITian. Best of luck. Thank you. Thank you for listening.